So this is our tutorial hub, and today I discuss about Cauchy Riemann equation, how it can be reduced. So let's start. In a complex plan, I have already started to discuss about complex analysis. So today we will prove how Cauchy Riemann equation can be obtained. So in a complex plan, Cartesian complex plan, we know that there is a real axis. This is a real axis x, and an imaginary axis I, y. This is imaginary axis, and this is the origin. So any point f, its abscissa is real, and its ordinate is imaginary. So this is a complex point. So uh, if we will go to the derivative differentiation of any function, take any function fz in complex plan. This is fz. So, and this differentiation can be done uh, with respect to the x-axis because this is the function of this is the there are two parts of the complex points or complex function fz, and one real and one imaginary. So fz can be written in part of two fz can be written part of two complex numbers u plus iv, where u and I also complex numbers. So u is also the function of z, u is also the function of z, and v is also the function of z. So the differentiation is very important. How the differentiation can be obtained with respect to the x and with respect to the y, the partial derivatives. So for this purpose, we can we already know about the in complex analysis that if the differentiation uh, has to exist, if f prime z, a derivative of z, has to exist, then if it has to exist, then its partial derivative with respect to the x means first derivative of uh, uh, del of fz with respect to the x must be equal to the imaginary partial derivative of fz. Imaginary partial derivative of fz. If both are equal, then we can say that fz has uh, uh, the differentiation at the point z. Otherwise, it exists at z at this with this condition that with respect to the partial derivative x and with respect to the imaginary axis y, both the different partial derivatives must be equal, and then we can say that at the point z uh, derivative of z exists. Now using this we will calculate the Cauchy-Riemann equation. So do this. So we know that del fz by del x equal to imaginary del fz by del y. So in the by the definition of the differentiation, we can write that limit uh, x tends to 0, a z plus e minus a z by e. Here h is real, not imaginary. Here h is real, is equal to limit. What we want to find out that z tends to 0. So we are taking just, z is uh, we are just finding z plus uh, del z, where del z tends to 0 and del z is equal to del z is equal to h plus I plus ik. The x and partial derivatives with respect to the imaginary axis. Here ik tends to 0. F z plus ik minus f by ik. So now, if this we have the information now. Now, using this information, we can write that in this way. Limit h tends to 0, f z equal to x plus iy. We have already taken that z equal to x plus iy. So this will be x plus h y minus a xy by x is equal to limit ik is to 0. There will be a x plus x comma or y plus you can say y plus k minus f xy by I. So now we can do this. Each. Now we know that if z is equal to u plus iv, we have taken that fz is equal to uz plus ivz. Fz is equal to this function is uh, each consists of two functions uz plus ivz. Then we replace this relation in this relation. Then we will get limit h tends to 0. Here we will get I'm separating also. It will have two parts u x plus h y minus x by h plus limit h tends to 0 u v, sorry, here will be I. I'm separating I, and there is I, so it will be v x plus h y u v x, then y x y by h. Using this again from the right hand side, we will get limit ik tends to 0. Here again u y plus k minus u xy by ik plus limit ik tends to 0. This will be v x y plus k minus v x y. There will be I. So I am below I. So I am writing here, not in front of the limit. V x y and here ik. So I cancels each other. I cancels. So from this we will get that partial derivative with respect to the x. So I am writing del u by del x plus I into del v by del x. Del v by del x is equal to some mistake I have done, not cancels actually. What will I have done mistake here? The second part there is I. Here there is I. Actually, what a ik. Actually, here will be I and here will be I square. Just remember that I already said that what I have said that del f by del x is equal to I del f by del y. So I must be in front. There will be I square. So it will be I del u by del y minus I square is equal to minus del v by del x. Now here we will get the Cauchy equation. So now finally it is evaluated. Just look this. We know that real parts equal to real parts and imaginary parts is equal to imaginary parts. Using this fact, we will get that very important relation del u by del x del del u by del x is equal to minus del v by del y, because real parts are equal, imaginary parts are equal. So del v by del x is equal to del u by del y. This is the important Cauchy-Riemann equation. Cauchy C, Riemann and R equation. Very important result and used in the complex analysis. Very important and very uh, is too much used in the complex analysis to solve any high level of problems in complex analysis. So this is very important, and I hope that I have make you all understood. So if you have any problem throughout the video to understand anything, then comment me in my comment box. Comment me. I further again, if you think, then I again go to make you understood. I hope that you enjoyed this video and like this video. I think enough clear it is how it is any equation. So any problem if you have the it is tough to understand. It's not easy. There are many partial derivatives also used. It's not easy. I can understand this. So that's why if you have any problem, then comment me and subscribe this channel to get such kind of videos first. Subscribe and share with your friends. Share with your friends. So till then, have a good day and thanks.